1528. Let's take a look at 1527, and it gives us a pretty good example here, really. You know, if you want to see what people are reading and whatnot, okay, without reading the whole problem, you guys can do that. And it's at the .05 significance level. But here's my data, right? I got city people, suburban people, and rural people. I got national news, sports, comics, and which they read first. And so I go ahead and I input that, and then I kind of move it, and I just add, and you could come to here and just add add a column into there to do some of this math. What I need to do then is total my each row, column, I'm sorry, these are the columns, so that's pretty easy. Okay, don't worry about these FEs yet. So I'll total my national news, I'll total my sports, and I'll total my comics, and I've done that. Okay, and then I need to total my city, and so this one I got to do a little, I got to, instead of doing the sum, I got to say it's this plus this one, plus this one, because I got to skip those FEs for now. Okay, and once I do the one, then I can carry it down. Okay, and then I'm totaling my totals, and it should be the same either way, right? I can either carry this down and it should be the same, okay, or I can sum those up above. Okay, there you go. Either way I get the same answer. I should. Okay, so 1024, what that means is that out of all these, okay, again, it's just the sum of these, and I could do that too. The sum of those is 1024. That's how many people I sample. Okay, well then what we're doing here is we're comparing the frequency, the actual frequency from our sample, from our results, to what the expected frequency might be. Okay, and how do we do that? Well, what we do here is we come up with the FE as our expected frequency in each of these cases. And what we do is we take our total of, take a look at this, it's our total of our row, okay, times our total of our column here. Okay, so I've got M2 times my G5 divided by my total here. Okay, that gives me an expected frequency because it's kind of at the crossroads, right, of rows and columns in each of these places divided by the total. Okay, so I'll just hit this. I'll go, this is equal to my M2. I'm going to want this one to change with me a little bit, so I'm going to do that times my column total, but this one's going to stay the same, my reference to that. So I'm going to use my deal and then divided by my total here, and again I'll use my F4. Okay, that way I can just carry this down. Okay, and so my expected frequency here's the frequencies that I got from my survey, and here's my expected frequencies, right? And that still totals the 420, which is what I would expect. I repeat that then for each of these, okay, for my sports and for my comics. So again, for my sports, then it's going to be my total here, okay, times my column total, and hit my F4 divided by my overall total, and use my F4 again, enter, and then I can carry that down, and it should still total that, and it does. Okay, so finish that with the comics. Okay, now we gotta make our decision rule. To do that, it's a chi-square test, and so we use our degrees of freedoms equal to our rows, number of rows minus 1, times our number of columns minus 1. So we've got 3 rows and we've got 3 columns. So I've got 3 minus 1 times 3 minus 1, or 2 times 2. So my degree of freedom then is 4, right? And so I've got a degree of freedom of 4, and my 0.05 is my significance. Let's go see what my chi is then. 0.05 degree of freedom for, this one comes up with 9.488. I think that might be a little different than what I have here. No, 9.488. Okay. So I'm going to reject it if my calculated x2, or x squared, I'm sorry, is greater than 9.488. Okay, how do I do these ones? Ugh, this gets to be a little bit more complicated. And the formula's in there. The expected frequency was easy to find, but the formula goes back to that same one that we had. It's 15.4. It's on page, holy cow, I gotta go way the heck back. Page 545. Okay, it's my F sub O, my actual, minus my expected frequency squared, okay, and then divided by my expected frequency, okay. So what's that mean? Well, when let's do it this way. So it's my F sub O minus my F sub E. So that's why I have this down here. So this is equal to this one minus this one, okay. And then this is squared, okay, then I just simply square that, so that's equal to this squared to the second. And then I divide that by, again, my expected frequency. So this, my result of this divided by my expected frequency. So it's equal to this one divided by my expected frequency up here. And I get 0.99. I got the same thing here. And what I did here is I just went ahead and put that whole formula in one. So I've got it's equal to my G2 minus my H2 parentheses. And that's squared. So I just use my little tenth thing and my squared. And then I divide it by my expected frequency again, my H2. Okay, and I get the same answer, and so I'm confident. All these should carry down, so I think I can just drag that down then. Yeah, and it just gives me the right answer. So yeah, I'm figuring out a number for each of these using that formula. Now I think I can also, because my deal should stay the same, all of my references should stay the same, I can copy this and then paste it to here, right? I can drag that down, and then I can paste it to here. Oops, I'll hit the copy again and hit a paste again, and then I can drag this one down. Okay, now the rest of the math becomes pretty easy. It's really just the sum of all these then is my calculated chi-squared. So I can say this is simply equal to the sum of all of these. 7.33992. Is that greater than? No. It's not greater than. So I do not reject the null. In this case, the null, stating these again is always kind of funky. So my question was, at the 0.05 significance level, can we conclude that there is a relationship between the type of community where the person resides? So this time I would say that my alternate hypothesis is that there is a relationship, and my null hypothesis is that there is not a relationship. Okay, which kind of goes back to being a little bit normal. Okay, so I would say do not reject the null, and the null is that there is no relationship. Okay, and so I would say that my calculated number is less than that, so I can't reject the null. There is no relationship.